everyone, and welcome to the January event of Leeds PHP. So today we have one talk with Thomas, who's going to talk to us about MySQL with bells and whistles. Then we're going to hang around for a chat after that. Our platform tonight is Big Orange Art, and their aim is to support and promote positive well-being and mental health within remote working communities. We have a Slack group if you'd like to join. The link is down below in the slide. So yeah, we're gonna have one talk tonight with Thomas about MySQL and bells and whistles, and then after that we're gonna hang around for a chat. So yeah, we can welcome Thomas in. Hi Thomas, how are you doing?
I'm well, thank you. Yourself?
I'm good. Very glad to have you tonight with us.
All right. So, should we get started?
Yeah, let's get started. I'll hand it over to you.
I'm sorry to interrupt. We just seem to be having a bit of an issue with the live stream at the moment. The player seems to have failed on the site. Want to just pause it? I'm going to very quickly take a look and see what's going on behind the scenes there, and then we will come back. Do you mind? I'm just going to take you off just for a couple of minutes whilst we just see what's going on here, because this has not happened before.
It's okay. That seems to be all resolved.
All right.
Let's get started.
Welcome. I can't see anyone, so I'm as far as I'm aware, I'm talking to a blank screen at the moment. Okay. I also realized I've got myself open in the other tab, so let me close that quickly. All right, so welcome to MySQL with bells and whistles on it. My name is Thomas Shone, and I'm a lead software engineer working at Booking.com in the Netherlands. I deal with a variety of topics about compliance, data modeling, finance, APIs, static code analysis, and pretty much anything else someone's foolish enough to let me play around with. So today, I want to talk a little bit about MySQL and the cargo culting that we get into around it. Anyone here who's worked with a database administrator before or with a development team that's been around for a while find that they tend to have guidelines about how you design your database tables and how you design your queries. And these guidances could be around things like casing, naming, foreign key usage, preferences for time formats, and so forth. And this does tend towards a kind of cargo culting approach, especially depending on how long it's been there. You might have a situation where, this is the way you do it. You've always done it this way. And the person who made the decision about how to do it has long since left the company. And you have no idea why you do it that way anymore, but you do it because everyone does it. So to kind of provide some explanation about why we do things certain ways and why those approaches might have evolved over time. I want to get into a little bit of the inner workings of MySQL, and just so you know, I'm busy trying to navigate 2 sets of slides here. So to better understand these guidances, we're going to look a bit at the core functionality of MySQL, how it works under the hood, and hopefully not leave us all too confused. There is some technical stuff. I'll try and keep it light. I'm not going to dig into too much detail. But yeah, there will be some technical related stuff in here. And then if we have some time right at the end, we can look at some cool tools that you might not be aware of that will definitely make your life easier if you're working with MySQL. Right. So how did I get started in this? Why am I talking to you about MySQL? Well, part of the reason I started on this adventure was because I was given the task of bringing some semblance of order to let's be generous and call it chaos of the bookings MySQL ecosystem. An ecosystem that resembles exactly what you think of when you unleash about 2,000 developers with no oversight, little in the way of standardizations, and give them a whole bunch of very heavy, very expensive, and very fast machinery. The last time, and by that means the last time I did it just now, I did a count of how many MySQL tables we have. It currently tops out at 290,000. Now, I also want to acknowledge that the only reason I have this knowledge is because I'm not some kind of MySQL engine whisperer savant. It is because I had the good fortune of working with some really talented people who have been very patient and answered my really annoying questions with very small words so I could understand them. So I just want to do a quick shout out. If you are interested in following some of the best in the field, there's Shone, who is a staff database infrastructure engineer at GitHub. Simon Mudd, who is one of our senior site SREs at Booking. Christian Kuntop, who also goes by Isotop on Twitter. In fact, one of his articles around UTF-8's multibyte 4 has been hovering around the Orange website and Reddit over the last few days. So you might have actually read something of his already. Daniel Eden and Matthias Jonsson. So these are all really good people to follow. They write very interesting pieces. Christian does mad things like say, well, what if we put the entire database into RAM and never run it on a disk? And then orders the hardware on Booking's budget. And then you get a database that's pretty much running in memory and is ridiculously fast. So on the next slide, just to give you a bit of a heads up, I'm going to be showing you a create statement for a MySQL table. And I want you to think about what is wrong with it. There's not much of a back and forth on this presentation, so I just want you to think about it in your mind. And then we're going to go through a couple of them of the issues that I identify with this table. So let's go to the next slide. And I'll give you all a few moments to look that over and decide what terrifies you the most about it. All right, so what are the things that terrify you about that table? Okay, straight off the bat for me, there's no primary key. Well, is there a primary key? Let's have a quick look at that slide again. There's also not much in the way of indexes, which for me is quite an important thing. When you have a table that you're going to be querying, you're going to need good indexes on it. But there's other issues like when you're using timestamps versus date times, when should you be using them using varchars instead of chars? The terminology used in the column name, singular versus plural, the fact that we refer to a language in the user table, but should we be referring to a locale? Because obviously a locale and a language are different. I mean, you might disagree with me, but I will start spelling color without the U in it, and then you see how you feel about it. Usage of text fields. Should we be using text fields? Do we want to have large blobs of text, or do we want to break those down into smaller columns? There's no default set. There's no nulliness set. Or should there be nulliness set? The length of the email field is wrong. Should things be enums instead of strings? And so there's a bunch of things that could potentially be wrong with how this table is designed. What I'm going to focus on in this talk, simply because we do not have enough time to cover everything, is going to be the primary keys and the index. So back to that first question. What is the primary key? Now, what we actually need to answer first is, what engine does this table use? Because what is the primary key will be answered differently based on which engine your table is using. Now, it could be using MyISM, which is the old table definition for MySQL, MyISM, InnoDB, which is a new standard. It could be using memory, which pretty much means the table is held completely in memory, and when you restart your database, that entire table gets flushed. Or it could be a type called black hole. Black hole is literally a table that has a table definition, but whenever you write to it, it just disappears into dev null. There are valid use cases for using a table like that, but it's generally not common. And if you're feeling really evil, create a table using the black hole engine name, and see how long it takes your colleagues to figure out why, when they write data to it, it just disappears. Now, since MySQL 5.7, the default engine for MySQL has been InnoDB 1. And since support for 5.7 was dropped in October 2020, I'm assuming you're running a more recent version than that. So for now, we're going to assume that this table is set up as an InnoDB table. So yes, that's the evil bastard table, if you're feeling evil. Now, the reason why you want to use InnoDB is for a number of reasons. And if you Google around on the internet, you'll get different responses. Some people say MyISM has faster reads, where InnoDB has faster writes. This is no longer the case. It was the case a number of years ago, but support and development in MyISM stopped a long time ago, and InnoDB now has faster reads. So that is no longer a reason to keep MyISM tables. In addition, InnoDB tables are ACID compliant, which, if you're familiar with databases, is exactly what you want whenever you're dealing with anything to do with data you cannot lose. It needs to be atomic, consistent, independent, and durable, which pretty much means if you're doing financial transactions and you're doing a lot of them all the time in actual database transactions, your data is safe with InnoDB. Obviously, it can do transactions, and it also does row-level locking, which means if you write to a row, you only lock that row. With MyISM, if you write to a table, any row in it, it locks the whole table, which means no other writes can come in at the same time, which makes it a very big blocker for tables that get a lot of updates to it. So straight off the bat, don't bother with MyISM anymore. Use InnoDB. If you want to see which tables you have in your database that still use MyISM, you can run that query. That will check in the information schema, which is a special schema which contains information about your database. And it'll literally return a list of the schemas and the tables that are still using the old MyISM engine. So to be 100% clear, this is an InnoDB engine being used for this table. So what's the primary key? Well, with InnoDB, InnoDB uses something called the clustered index. For most cases, a clustered index is just the primary key, unless you haven't defined a primary key, in which case the clustered index, the creation of the table goes into the search pattern to try and figure out a way to uniquely identify records in the table. So if you haven't specified a primary key, MySQL goes and looks to see, is there any not null unique field in this table? And if there is, that becomes the clustered index. And if you don't have a unique a not null unique column, it will then go and find an appropriate index. Because InnoDB cannot function without the equivalent of a primary key. And if you don't specify one, it will try and figure out how to create one for itself. What this does mean, however, though, if it can't find a good index for it, it'll create an auto-incrementing ID automatically, but then it'll hide it from you. So if you don't specify a primary key, you might end up getting a primary auto-incrementing primary key anyway, but not having access to it. So it's wasted space for something that you should have defined yourself anyway. So probably another good thing to check is go and check if you have any clustered index, any tables with clustered indexes set up. This means it's pretty much had to create its own primary key, which is wasted space. You should just create a proper primary key for that field. Please be aware, though, you can't alter a table that's had a clustered index set up on it. You literally need to create the whole table again from scratch and repopulate it. So it's additional pain. This is something you want to avoid having to come back and deal with later on. And now you might think, why does InnoDB need a primary key? Why do I have to define one? I mean, I could use the clustered index one, have it also create one and not have to deal with it. Yes, sure, it'll take up some space, but what's the worst that can happen? Well, there's a couple of major problems with this. InnoDB inserts use a mutex lock. And if you has to use a clustered index that is created itself or using a robust index or a unique constraint, you're going to start ending up with massive performance issues once you start writing to that table a lot. So that's one major issue. If you're using binary logs, you're going to have those binary logs are going to be much bigger because you're going to have to capture a lot more information in the binary logs for things like updates or deletes, because it needs to know more about the table because there's no index to reference it. If you're doing replication, you're going to have a lot of performance issues. In fact, if you're running MySQL 8, you cannot run replication on a table that does not have a primary key. So if you are planning to update to MySQL 8 at some time in the future, and you're using replication, it's going to break. And if you're using clusters or any form of clustering, transactions become ridiculously slow, 100 times slower than normal. So generally, to avoid all of this pain in the future, make sure that all your tables have a primary key. In fact, one way to make sure that you don't have this problem, is you can set this property. So this will actually prevent anyone from being able to create a table in your database that does not have a primary key. This is for MySQL 8 onwards. Now, I've noticed something that the slide sharing of this program is also sharing a whole bunch of slides that I hid. So I'm going to have to jump through a couple of slides that are not relevant, that I just cut out and didn't properly remove from the presentation. Right. Like, for instance, I'm not going to talk about that. That there be dragons. Now, let's talk a little bit about search, because once we have our table and we have it up and running and we start using it in production day to day, you're going to start noticing performance problems with your table, especially as they grow, based on how you've indexed it or not indexed it. So to understand how we can create good performance searches, we need to understand how MySQL does searching. So MySQL has a fairly simple method of collecting data. Over here, you can see, I'm not sure if my pointer actually shows up. Is there a pointer mechanism? Can't see. Up in the top left-hand side, you have your clustered index or your primary key index. So if you've set a primary key, it's your primary key index. If you haven't, it's a clustered index. And that is a balanced tree that allows you, when I say, hey, here is a identifier, please go and get me the data for this record, it can very quickly find which memory address in the leaf that particular row is. So if I give you an ID, it can very quickly go and look up that row and return that result. So generally, the fastest, most performant way to get a result is to select on the primary key. because it only has to go and look at the primary key index, and then go and retrieve that particular memory address from disk. Now, if you're querying and you aren't using the primary key, you're using some columns that fit with a specific index, then you start off looking at the secondary index, and you'll quickly navigate your way through that index, that balance tree, find the primary key value for the ones you care about, and then go and look at them up in the primary key index, and then collect the row from disk. So indexes are slower than the primary key lookup, but they're still fairly fast. If you're not querying on the primary key and you're not querying on something that can match a secondary index, it then has to load every record in the database, in the table, and go through them one by one. And that is the slowest, normally the slowest way to query a table. That's the one you generally want to avoid, especially on high performance, large, complicated tables. Now, there's also something called selecting within an index. So, and this actually makes it even faster to query. And also leads to one of the most common cargo culting methods I've seen. If we have this simple table and you have a primary key of an ID and you have two fields, and those two fields are part of an index, if you do a select star from that table on one of the fields, it'll use the index. It'll use the index, it'll find the primary key value, it'll use the primary key index, and it'll look up the record in the table and it'll return it. So for those first two queries, that's what it'll do. But for the second two queries, those will go and look up so for the first one, we'll go and look up in the table, the index for fields 1 and fields 2. It'll filter for them, it'll navigate through them, and it'll find the primary key value. But because we've found the primary key value is stored in that index already, and so all the values for field 1 and field 2, we don't actually need to go and look up the record on the table, because we already have those values. They were part of the index already. So if I select from within the constraints of the index, we don't have to go and look up the rows. We can use just the index to return the results. So this is quite often where you say people saying, don't go count star, go count a field name or the primary key. Because what that normally means is if it's using an index, and all of the fields that you'd care about are within that index, it doesn't have to go and fetch the rows from disk. It also means that people misunderstand why you want to specify, put the primary key in there, because you might have other fields in the where statement that still require you to go and look up the records in the data in the disk. And so when people say, hey, don't use star, always use the primary key, what they're really meaning is if your index fits within your filters, fit exactly an index, then you don't need to go and collect stuff from disk. Now, those indexes that I was talking about use something called the balance tree, and you actually don't need to know anything about this, but it's really cool to know how balance tree is. It's not a B tree, it's a balance tree. And how a balance tree works is you have these little nodes, and the nodes will literally contain a couple of records and say of values. So in this case, this would be an integer index, and I'll say, right, your values range 46, 53, 57, 83. Now, if the value you're looking for, let's say the value we're looking for is 43. You'll start at the top of your branch node and go, right, 46. Is it greater than 43? Yes. Go to its leaf. Inside the leaf, it'll start at the top and go 40. Is the value 43 less than or greater than 40? If it's greater than 40, it goes to the next record, and it goes, is this the same? 43? Yes, great, it is. That's the point on the disk where you can look up this row, this record. And the nice thing about the balance tree is you can very quickly navigate it to find a value, even if you have a ridiculously large number of records. And what tends to happen is over time, as you insert more records, the balance tree has to rebalance itself to make sure it's fast. What you don't want is multiple layers, because you will have multiple layers. as it gets bigger and bigger and bigger. You want each of the nodes to be quite small, so it's a balance between how deep the tree is and how wide it is. And the nice things about this is you can have up to over 1 million rows, and your tree will only need to be a depth of about 10. And it's the size of each leaf will only need to be 10, which means to find the worst result, the hardest to find record in any in a table this big would require 10 times 10 checks, so 100 checks, and that's the worst case. Now, so now that we have a better idea of how indexes are built and also why we need primary keys, now it's a matter of deciding what we actually need to index, because we can design tables and we can get a rough idea before we even start using it, what we're going to query it on. You know, what are the fields we're going to query on? What are we going to try? How big we think it's going to grow? What are the the order of things we always search on? But that's not necessarily always the real life situation. We'll find over time that the indexes we created might not be sufficient. They might not cover all use cases, or they might not be used at all. So now I'm going to talk a bit about how we identify which indexes we actually need. Now, obviously, the best way to find out that you have a problem like this is via people complaining. If a user complains and says, look, it takes hours for this page to load, or it used to take a couple of minutes and now it's taking hours, or this used to be instant and now I have to sit around waiting for a spinning wheel. That's generally an indication that's something started off fine, but as the table grew, it became less and less performance. It might be personal experiences or frustrations with specific tools you use yourself. Resource hogging. So if you see that these huge spikes of demand on your database at certain times, maybe during scheduled crons or via specific times of the day, that might give an indication of things you need to go and look at and deal with. You might have slow running processes. So a cron or a batch process that used to take a couple of minutes is now taking half the day, and now and that becomes a problem because it starts running into reruns of the process. Or you need to have these numbers done by a certain time, and if it's not, then you have run over. But generally, treat optimizing queries like you treat optimizing anything else. See if there's a problem, and then triage it, rather than try and figure out everything, all the things you need beforehand. You can design for things you think it'll be required, but don't overdo it, because your indexes themselves take space, and every single time you do an update or an insert, you also have to update or insert. You need to modify your indexes as well. So the more indexes you have, the bigger your data is, and the more time it takes to do things like updates and inserts and deletes. Probably the easiest way to figure out if you have a problem with a query is to run an explain on it. And explain is a really useful tool. It pretty much tells you what the MySQL query engine is going to do with this query. And here I got 3 very simple examples. The top one, select star from user where name equals Bob. And this tells you what type of how it's going to break down this query. If you have a join statement, by the way, it'll list multiple entries for each table, because each table can use its own indexes when constructing a result. So the first one is a simple query. There's no possible keys, which means that there's no index it could pick. What it normally does is it will list all the possible keys or indexes that it could choose, and then it tells you which one it did choose in the end. So in this case, there's none. And in the end, it didn't choose one. So key and key length are also null. Then it says rows. And rows is the number of records the table returned when I ran this query before it filters it manually. So it had to return the whole table and then filter it. And the filtered one tells you what percentage of the records of the rows that were returned were actually valid. So in this case, it's an estimation, but it pretty much means about 3. I think it's about 3 of the records had name Bob Smith, which is pretty lousy. What it means is I need to have examined 1,582 rows to return 3. And then on the extra there, it gives you an indication of how it ran this query. It said it using a where, the where statement, and that was what it used to filter. And then it used a file sort. This is generally a bad query. This means that if our table is going to keep growing and we want to keep querying on the name, we probably want an index on it. The next field, the next query is a slightly better one. It is using an index. You can see there it says index. Possible keys, there was a key or index on the email field. It ended up choosing that one. The key length is 256 because it's a string. So number comparisons are obviously much faster than string comparisons. It returned one row, and it returned 100% of the rows that it returned. And it also says they're using an index. That's great. That's a good query. That one's using a meaningful index, and it doesn't require a lot of file sorting or manual parsing of the results. And then finally, the last one there is select star from users where ID. Now, ID is the primary key here. It says very clearly, select type is on the primary key. The type is constant, which is the best type of lookup that we want. It's using the primary key field, return one row, gave you all 100% of those rows. And yeah, there's no problem there whatsoever. So the explain function, in front of your query will give you a breakdown of how your query will be executed on the MySQL engine. It's also useful for figuring out which index a query is actually using, because Google sometimes has conflicting indexes, and it needs to figure out which one is the best one to pick. Now, sometimes the MySQL engine gets it wrong. Not normally. Normally, you don't want to try and force it to use an index. It's making an educated guess based on which one it should use. But you can provide hints to MySQL about which one to use. So you can specify in your statement, use this index. And that will be considered a hint to the engine. Please, if you cannot make up your mind, use this one. And this you can sometimes use if for very, very weird reasons, MySQL engine occasionally freaks out and chooses the wrong index, or at least chooses the wrong index for that specific query, based on what the contents of your table is. Sometimes you can also force it. You can say, do use this query. Ignore all other ones. I want you to use this index. This is the index I want you to use. This is useful if you want to drop an index and you want to see that the alternative indexes are still able to carry the load. So if you want to see, hey, I've got two indexes. It always uses this one, but I want to see how it performs with this one. You can use the force command. You can also say ignore an index. So if you want to see, the same thing applies. If you want to drop an index and see what it'll do if this index isn't available anymore with your queries, this can be used to just say, look, ignore this one for the moment. How would you run this if this index wasn't available? So these are useful tools to use, especially before you decide to make big changes to really large tables that could take a while to fix if everything goes horribly wrong. Another thing you can do is you can enable logging. So MySQL comes with a lot of built-in logging. One of the ones I really like using is the slow query log, the long query time log, and the minimum examined rows limit. What this means is if a query takes a particularly long time to run, I want it logged into a specific log file. If the results, i.e., it has to examine a lot of records and only returns a small number of them, I want that to trigger as well. That will give me a heads up that there's a particular problem. And if there's any queries that don't use an index, please tell me about them as well. And those will all be dumped to your to whichever log file you specify. And that's really useful to get a base level of where your issues are. This can be actually set up, I believe, while your server is running. So if your server is currently running now, you should be able to turn these on, monitor it for a bit, and then turn them all off. You don't have to restart your server. But some configurations do require you to restart your server, so do check the documentation on this. Another really cool one, and this one will require you to restart your service, is the performance schema. And the performance schema is a set of in-memory tables So when your server restarts, you lose all the data in them, that keep track on how well your server is running, how well the queries are performing. And this is really useful if you want to really get your hands dirty with how your queries are performing, especially when you can't really, you want to see what the actual live impact is, because this you run on your production server, not on your test server. This will give you live data about how well your servers are running in production environments. You can check if it's running on your current server just by using this command here. I will share the slides after the talk, so you don't have to sit here hurriedly trying to write all these down. I will share them with the presenters after the talk. I mean, with the group after the talk. One of the key tables I think is really important from the performance schema is the event statement summary by digest. And just a warning, most of these tables have names like this. But what this pretty much means is, if I take all the queries you run and I take out the specific parameters you're passing in them, so if you're running a select star from users where a name equals something, but the name keeps changing, I want you to aggregate all of those under one record, and then tell me how many times we actually had to do a full table scan for this. So this first query here returns, excuse me, apparently I can't click. 700 times. This query was run a number of times, and there'll be another one called count, which will say how many times it was run. But 700 of those times, it had to do a full table scan. So this is a good way to see what are the queries that, one, are used frequently, and two, are doing full table scans. And the second query here does something very similar. The only difference is it looks at how many rows were examined, i.e. how many MySQL had to load off the disk to look at, versus how many it actually returned to you in the end. Because if this number is particularly large, it means it had to look at a lot of rows to return a very small set. And this also helps you narrow down tables that might have indexes, but maybe those indexes are not the best possible indexes. They might have very low cardinality, and cardinality is something we'll touch on in a moment. Oh, talking the devil, cardinality. So cardinality is the uniqueness of a column. So the best way to describe it is if you take the distinct number of records in a table and you divide it by the total number of records in the table. And if your value is 1, you literally have a unique column. That column only has one entry for each value. So you'll never have duplicates. Those ones are great to have indexes on because it means that if I say, hey, give me a record for this name or this person or this number, you're always going to get one record, and it's going to find it very quickly. It doesn't have to examine multiple additional rows. The exact opposite of that would be something like an isActive field on your user. IsActive field has two values, true, false. And the problem with true and false is you potentially have a lot of both. So if I want to say, please go and get me all the records for people who are no longer active, you're going to get a large results back. And if you want to filter that further by saying also who are maybe based in the UK, if your index is on the isActive and none on the UK, it's going to have to get a lot of records and then filter out just the UK ones, which it would probably be better to have an index on the UK customers and then filter them based on whether they're active or not. Or you might have a non-uniform distribution between your values. So you might have a situation where, yes, you have a true or false, but like isActive users, but you only have, let's say, 1% of your users are actually not active, in which case it's very quick to get the non-active ones, but very slow to get the active ones. In other words, you'll get a very large set that you might need to filter further. So you might want to have indexes on different fields, or have a compound index where you say, we have an index for both the isActive and something else. And we'll probably want to prioritize the something else sooner in the index, because it reduces the set a lot faster, saying, give me all the people who are in the UK and then all the people who are not active, as opposed to say, give me all the people who are not active, which will be a big set, and then give me the people there inside that which are in the UK. So let's talk a bit about what options you actually do have for creating indexes. You can obviously just create an index off a column. That's your most basic one. But you can also combine multiple columns into an index. And what that means is when you run a query, it'll first filter on the first column and then the second column if you're providing both columns. If you're providing just the first column, it could also use that index. But if you're only providing the second column, it can't use that index, because the indexes will be set up where the first part of the balance tree will be column A, and once you get down past that, the second part of the balance tree will be column B. So it can't get to the column B parts if it doesn't have the column A parts. So be aware, combined indexes are much more powerful, get you results faster, but they can only be used if you include all the columns from the left, at least the columns from the left to the right. If you have a column, if you have 3 columns, column A, column B, column C, and you only provide column A and column C, you can only use the column A part of the index, and then you get the result, and then you'll have to manually filter on column C. So generally prioritize it in the order of how you query the most. What are the fields you query the most, and which have the best cardinality. You can also do truncated columns. Truncated columns are more useful if you have big text fields, because big text fields mean big indexes. And maybe if you have, for instance, an index on email addresses. Email addresses are 254 characters. They're really big. You probably only want the first 12 characters from that string as your index part, because most email addresses are more unique at the beginning than the end. Most people have something at Gmail or at Hotmail or something that's more common at the end, where the stuff at the beginning tends to be more unique. You know, maybe you got a lot of John Smiths, but you generally will have more unique beginning part of the email addresses. This keeps your index sizes smaller, which is nice and is specifically important when you're really dealing with things at very large scale. But it does mean that you can't use just the index to return the results anymore, like we mentioned before, because it's not the full set of data, it's just the first 12 characters. And be aware that when you design and choose your primary key is being added to the end of all indexes. So if you think about a combined column, just in your mind, mentally imagine the primary key being the last column on the end of it, because it needs that value to then go and look up in the primary key index to then find out where it is on disk. And the size of your primary key means it'll impact the size of your index as well. So if you have a primary key that's on an email address, you can have much bigger indexes. So if we ran this query, and I get that it's not great to have back and forth questions on this, which index would be used here? Now, as I was mentioning with combined indexes, it starts from the left to the right. So the index this one will use will be the index email name, not the index name email. I just see there from a Q&A from Mark, do truncated columns work cleanly with UTF multi-byte 4 character 6? It says. Yes and no. It's slightly more painful with that one, because yes, it would accidentally truncate and split some of your characters, especially if you have a multi-byte character that's 3 or 4 bytes. If I remember correctly from discussion with Christian on this one, is that limit is a character limit, not a byte limit. So I think it's fine. So because it's not doing bytes, it's doing characters, but I will need to double check on that. And that's a very good point. If you want to do proper UTF-8, your encoding for your column should be UTF-8 multi-byte 4, which is the proper UTF-8 for MySQL, and is called that for historic reasons, and they're not going to fix it retroactively because it'll break other people's databases. But that was a very good question, and I will actually have to look that up, because I know it's one way or the other way. I just can't remember which one. I think it's the safe approach. It does it on characters. So yeah, let's go back to that table that we looked at previously. This, I think, would probably be a slightly better way beyond the other problems with the table of how to fix this. We should definitely create a primary key for the table, and we should probably add some sane indexes to it: email, name, country, ISO, and province. Actually, I believe that is a slightly better one. So yeah, I would create a primary key, name, email address. I'll remove the unique constraints and put it down here. That's a personal preference. You can do whichever. I would add an index on the name, truncated to 16 characters. And I would add I don't think there's many cases where someone would want to query the province without understanding which country they're in. So I'd probably put the country ISO code first, and then the province. And I'll change from using yeah. That would probably be a slightly better design for your user table than the previous one. Now, we've talked about how we can create columns, indexes, and how we can determine which indexes are being used, and how we can identify if there's a problem. But let's get a bit more into how indexes are actually selected by the engine. So MySQL only use one index for the where statement. So if you have select star from table where whatever's in the where, MySQL will always limit itself to one index. It doesn't matter how many indexes you have on how many columns that you might be selecting on, it will pick what it considers the best. We'll start by checking if you've hinted or forced an index. Then we'll try and find one that matches the where statement exactly. And if it fails that, then you have a situation where one or more indexes does a partial match of the statements. So you might be selecting on 3 columns, but you can find an index where 2 of the columns apply. Starting from the left-hand side of the index, and then it tries to pick the index with the lowest cardinality, i.e. the most chance of getting unique results, not having to return a big result set and filter it further. And this it does by looking up the cardinality on the index in the sys InnoDB statistics table, which actually specifies the cardinality of each field. But you can calculate it yourself, as mentioned, by doing a distinct count of the columns divided by the number of distinct count on the actual column name divided by the total number of rows. The order and group by also can use an index, because once you've got the results and you want to order it by, for instance, first name and address or something like that, it can also use the index to sort that, because the index itself is a sorted list of entries. So it can very quickly take the IDs and work out their order. But it always only uses the leftmost column. So your group by and your order by, if you have a column, if you have an index or a compound index that starts with the first columns of your group by and your order by, it will use those indexes to speed up that performance as well. Most people don't realize that a lot of the time spent can actually be in both the grouping by or the order by, especially if you have a particularly large result. The ordering can be expensive. And if your explain query in the extras area says file sort, it generally means I've had to go to disk and do file sorting there, and that's generally a sign of badly performing order. Once again, a lot of this won't be a major issue if your tables are small, but as soon as your tables start growing up to the hundreds of thousands, millions, tens of millions, in my case, I've got a couple of tables that are close to 500 million records. Then you start to notice these small things. Right. How do we evaluate an index? I mean, we've identified there's a problem. We've created an index. We know roughly how MySQL is going to select them. We can check for it. How do we know the index was good? Well, I mean, all the stuff we learned about in identifying when we need an index is relevant. But we can also check for a couple of other things, like, is the index redundant? There is a possibility we can create an index that will never be used by MySQL because there's always a better option. And you can check that by running that query. There's a schema called sys, which contains a table called schema redundant indexes, which literally lists out all the indexes that are redundant and why. What's the index that's better than it in every case? And these can be situations where you have two indexes, one for a field and one for a compound field, one for a column and one for a compound index that starts with that column, in which case it doesn't matter which one MySQL uses. And you're just wasting space. You can also see if the index actually gets used by looking at the performance schema. You can run that query that literally says, hey, if this query has never been used since the database was last restarted, then maybe it's not used. That's a good real life example. If it's never used, why waste space using it? Obviously, if you just rolled something out, then you're not going to have any records for it. But if it's been out and live for a month and a specific index hasn't been used, you can probably drop it safely. Aware, this has to be on your production database. Don't run this on your development environment and then wonder why all these indexes aren't being used, because unless you're using them in your development environment and your development environment doesn't get restarted often, it's going to give you false results. I'm not going to talk about relationships. I'm not going to talk about scaling, but I am going to talk about cool tools. Now, before I get too much into the cool tools, if anyone has any questions for this, please feel free to drop them into the chat and Mark will ping them to me. We will have a Q&A section at the end, so I'll happily stop and go back through them. But now let's talk a little bit about some of the cool tools that are available for MySQL. And I'm going to start off with one that hopefully you're all familiar with, and that's MySQL Workbench. If you work with MySQL a lot, this is a very nice tool. It combines a MySQL administration board with a query browser with a design tool. And because it's tightly coupled with MySQL, it allows you to do things like take a database and turn it into a diagram like this with all the relationships and shown, or design one and then turn it into a database automatically. So this is really nice, especially if you like the starting with the design phase of your database and then persisting it to disk. Excuse me. Also, more importantly, it's a supported MySQL tool actually built by them. So it's generally had some good love over time. I think they used to have one called MySQL Query Browser, which they kind of rolled into this. So if you're familiar with the old MySQL Query Browser tool, it now lives in here. Now, if you own a database in production, I hope you have a backup solution. Everyone should be backing up their databases. And hopefully you have something professional off the shelf or some database administrator doing this for yourself. But if you're a small shop and you literally are a one-person show, here's a very, very quick way to create a database backup tool. So MySQL Dump is a command line tool that there are a bunch of command line tools, and there's ones for very high performance and very large databases. But if you need something very quick and dirty, the MySQL Dump command line tool pretty much allows you to dump MySQL databases very quickly to disk. It pretty much writes out your entire database as a bunch of SQL statements. And this would make a very quick example of a backup you can automate. Obviously, make sure your backups leave the server you're making the backups on and go somewhere safe afterwards. But it is a cheap and quick tool if you don't have something right now, because you should have something right now. So if you don't have something right now, do something like this for now and make sure you have on your backlog to get a proper solution in as fast as possible. Then there is this tool called Cadfel. Cadfel is, I suppose, the best equivalent would be a static analysis tool for your database. And what this does is it pretty much all the stuff, some of the stuff we talked about today and a lot of other stuff, it will scan your database and tell you what the problems are. So, an example here, here's some results saying, hey, I found some tables that don't have primary keys, and then provide references and description about why you should have them. And it's a really nice tool. And I would show a demo, but I don't actually know how to share my screen on this. Actually, there we go. Try not to break anything. All right. Is everyone seeing? Oh, okay. Whoops. That away. All right. So here's a public database running in the UK at one of your academic institutes for the Genome project. And a very quick run here will give you an indication of all the problems with the database, including things like you have these fields should be unassigned integers because they're auto-incrementing fields. You have very badly defined primary keys. You're running a very old version of MySQL. And this gives you just some general feedback about the problems with your database. Online schema changes or Ghost. So there's a couple of tools out there in the marketplace that allow you to do schema changes on very large data sets and while in production. This is one of the painful change management processes that we have sometimes. We need to change a table. We need to add a column. We need to remove a column. We need to change the types of a column. And generally, if our tables are big enough, it results in locking. Because as soon as you alter a table, it locks the table and makes the alter. Now, this is fine if your table is tiny. And by tiny, I mean anything smaller than 100,000 records. It can generally do it quite quickly. You want to be safe, obviously, with your data, and it's probably better to add a new column rather than alter an existing column and then drop the old column when you're happy with it. But in cases where you, like me, have something like a table with 500 million records and you need to alter a column, that's a table that's been written to many times a second. You can't really lock it up for any period of time in a production environment. So there are tools like this which will do the equivalence of creating a new table, your new designs table, copying all the contents from the old table into the new table, and then atomically swapping the tables around. So you can literally hot swap in your table with its changes in live environments and your locking time is only the renaming of your tables. Obviously, if your code isn't ready to deal with it, you'll have other problems. But these are things we use when we have tables that can quite literally take a month to alter, depending on the size of the table. So there's a couple of tools available there. There's Picona's tool, which is the PT Online Schema Change. Facebook has a tool called OSC. And GitHub has a tool called Ghost. So what did I cowardly skip from this talk? Because I most definitely skipped a bunch of things, as you might have noticed in some of the other slides. I didn't talk much about what types of fields you could use for primary keys. I'm of the opinion that generally you want an auto-incrementing ID. Unless you have a very clear identifiable field that's not overly large and complicated. I haven't talked anything about foreign keys, mainly because Booking doesn't use foreign keys because it's a limitation on how we design our tables because we have multiple schemas. You don't get 290,000 tables without having to split them across multiple schemas, and relationships don't work across schemas. I spoke next to nothing about date time and timestamps because it's time and there be dragons and that is religious war ground. There's a lot of religious wars in that area. I didn't talk much about scaling, things like size estimate, data types, normalizations, how to scale to 500 million rows, for instance. And I very, very lightly brushed upon some of the schemas, hidden schemas in MySQL that you're not normally aware of, things like the information schema, which contains metadata about your tables, the sys schema, which contains information about some of your indexes and some things like the redundant indexes. And then the performance schema, very lightly touched on. It's got a bunch of really awesome stuff in there, but it's not the most accessible a bunch of tables, as you saw by the couple of queries we had. So if you want to know about any of those things, just not about time, please. I'll be hanging around afterwards. So we're going to have a Q&A. Throw those questions my way, and I'll probably be at the social as well if you want to bug me about any of those things. All right. Do we have any questions? Or are we going to do the Q&A separately?
Hi, thank you for that. That was very interesting. We've got a couple of questions that have come through in the chat, and if anyone else has any other questions, just pop them in the chat now, and I'll ask them as well. So Brian had mentioned that a backup solution is only as good as your last restore test.
Yes. That's actually something that I did leave off there is, yes, having backups is the first step. You need to be able to make sure you can actually restore from your backups.
Yes. Mark has asked, are there any benefits of using a UUID instead of an auto increment for primary key?
That is a slightly contentious issue, and it also depends. Are we referring to the original UUIDs or the new UUID specs that are still in RFC? Because UUIDs are strings, or I mean, you can have them as binaries. Binary 20 is the preferred format to use them in. In fact, the Catful tool actually says if you've got something that looks like a UUID and you're using a string, you're doing it wrong. Yes, UUIDs are acceptable alternatives. One of the things UUIDs don't have, at least in the current versions, is audibility. How they're created doesn't make them nicely orderable. So you can't order them in the order they've been inserted, even if you use the time-based UUID, because it doesn't scan nicely. It's Indians are the wrong way around. But the new UUID specs that are coming out now, which is UUID 6, 7, and 8, actually have a way to deal with that now. And they're created so you can actually have time-based orderable UUIDs. Just use binary 20 to store them. Don't use text. And use the MySQL functions to turn them from binaries back to UUIDs and from UUIDs to binary.
Cool. So another one from Mark, you mentioned earlier that use of index can be a lot more interesting when your query uses joins or subselects.
Yes. So yeah, joins, obviously each table gets to pick a index. And so with join queries, you do want to run and explain. You want to look through every record there. So obviously you could have a very good set of joins with very nice index selection, and then just have one really bad one, which will ruin it for all the others. So that explain box will expand out for each table you're selecting on, and give you an indication whether it's using a good index or not. Subselects, generally, I try to avoid subselects if possible in MySQL, because then we deal with temp tables, and this is where we get a bit religious around subselects and temp tables and what different ways you can construct your query. So, for instance, I deal with a lot of big data people, and big data people like to write subqueries inside subqueries inside subqueries, and they generally make me sad. But then they're running that on Hive and not on MySQL, and I go, okay, that's fine. You can make those poor servers over there cry. It's not for real-time data.
Cool. I think that's all of the questions we've got so far. Thank you for sharing that talk. That was very interesting. There's a lot of good information in there. If anyone wants to hang around afterwards, the social tab will be open. I think Thomas said he'll hang around for a bit if anyone wants to chat about MySQL. And then apart from that, we'll see you all next time.
See you next time.
Thanks, everyone. It was lots of fun, and thank you very much, Hugh and Irene, for having me.
Thank you for being here.